Can you record, Christina? So I just want to point out that I totally am using the wrong computer today because I messed up my computer. It is very sad to me. It's in the shop and we'll come back in a couple of weeks. So bear with me if this is a bit awkward because I'm teaching with a very awkward computer, but I digress. So you guys know that this week is tidying data, which is kind of funny because you guys have been using really tidyverse the entire semester, but maybe you hadn't really been thinking too much about how you were using tidyverse because the commands you were using were very simple for the most part. So you weren't doing too many manipulations of your data. But that, it's not like you haven't seen tidyverse before. It's just maybe now you're seeing it in a more, formal setting because probably for the rest of the course, you'll be manipulating your data in a very systematic way, right? So tidyverse is obviously by its name a way to make your data tidy, but in a way, but in some sense, it's a way to make your data tidy in a very tidy way, right? So if any of you try to do too much data manipulation in base R, you'd run into the problem that you have too many lines of code because it's clunky. The wonderful thing about base R is that, about tidyverse is that it allows you to actually manipulate your data from left to right and within the same pipeline, almost like an SQL sequence. And in this way, it makes the features of your data analysis much easier to deal with, and you end up with less lines of code. So when you go back and look at your work, it makes a lot of sense to you because you didn't make too many commands or too many lines of code that becomes clunky when you go back and look at your stuff. So because you guys have been using tidyverse the entire time, even though you don't know it, you would notice that, oops, this is not necessary. You would notice that the package is tidyverse, right? So it's an external package, but actually, ironically, it's a compilation of packages. It has things like, ggplot, tibble, dplyr, tidyr, and it has a whole bunch of features that because it's from the same guy. And if you look at Ken, I will actually pull up Ken's notes because he does have it there. So if you look and see, it's actually coming from, where does he bring him up? Yeah, Wickham, basically. His name is Hadley Wickham. If any of you are kind of Twitter addicts, you'll see him there. He heard this basically this universe of making your data tidy and not only tidy, but making your data look nice, right? So ggplot is within tidyverse. And so you can do really radical things in terms of data manipulation and even data visualization with tidyverse, right? So let's start. I think there's an issue with Ken's data frames in a sense that if I try to click on the data frames, it doesn't actually load. Let me just double check. So it was an issue. Yeah, you can see there's an internal server error. So I'm probably gonna send him an email about that because it will be difficult for you to go through his lectures, right? Until you actually have access to the data frames. That in the meantime, I will just point out a couple of things in the data frame he did actually post because he at least posted the actual output. You can see what it's supposed to look like. The first one is a pig's data, and in particular, it's looking at like how much do the pig's weight vary according to the feed it was given, basically, right? So you're looking at the weights of 5 pigs according to feed type, right? So you have 5 pigs that were given feed 1, 2, 3, 4, 5, and now the question is, do the pigs weigh more on feed 1 or feed 4, etc. Right? So this is not tidy in the sense that, like, you can see it's presented in wide format. So the things you're used to doing, like, aggregating your actual data in terms of the grouping, so you can compute means across each group. You can't do it as it currently looks here because it's all your, if you have a variable called feed and you have 4 different levels, instead of the levels being presented in the same variable, it's presented across different columns. So this is not tidy. We need to find some way to, combine all the actual different feed types so that we have one variable, and then we have the weights across each different feed, and we can actually check how much do the pigs weigh according to feed type, basically, right? So there are two functions within tidyverse called pivot longer and pivot wider, right? So depending on how you actually want to present your data, most of the time I'm going to admit we care about the longer format, but it's important to know how to go back wider as well, because sometimes we do use wider, but it's just most of the time we care about the longer format. You can see that we know that there are 4 different feed types. So if we have a variable called feed, there are 4 different levels. This is why you have to first give the function how many different levels you want to combine the variable across, basically. So we're going to combine it across the 4 levels, and we're going to call it feed, basically, right? And then the values are going to go to weight, right? So these are variable names we created for ourselves based on these levels here, right? Now we can't actually, I wonder if we can do that in this data frame here. I'll see if we can do it in another data frame. But so this is, we don't have access to this particular data set just now because it looks like there's an internal server error. But I did actually pull up a data set within tidyverse, and you can actually see that tidyverse has its own built-in functions. In particular, it has one function called, it has its own built-in data frames. One data frame it actually has is something called fish encounters, right? So fish encounters is what you see here, obviously, right? So I'm going to run it, and you can see that it has this thing here. You can see that this is already actually in longer format. I know this because if I look at station as something like kind of like a variable with different levels or classes, it's all in the same, variable, basically. So the variable have different levels, are just obviously categorical, and it's presented like that. This is obviously wide format. So this is long format, sorry. And what are we looking at here? We're looking at how many different fish sightings people saw, right? So these represent the fish types. And if you look across the different columns, you'll see that obviously the labels change, right? So there's different types of fishes, and they've been given their own labels. And then whether or not you spotted those fish in a particular station is given as scene 1. So if you saw, for instance, fish 4843 in station MAE, you get a scene of 1, right? So if you didn't see it, it'll just say, it would just not show scene of 1. It will show scene of 0. Well, actually, it doesn't even show scene of 0 here, but you'll see what happens if we go to longer format. If we go to wider format, you'll see what happens, because they only really encode the ones here. But obviously, if you didn't see a particular fish in a particular station, you can imagine that scene is equal to 0, basically, but it's not encoded here, right? So when you go to wide format, it will actually say NA when a fish was not seen at a particular station, obviously, and we had to treat that somehow, basically, right? So this fish encounter is already presented in long format, so that I'm gonna do the opposite of what Ken's lectures has. I'm gonna show you what it looks like to go to wide format, basically, right? So let's suppose we want to look at our data in a wider format. So obviously, like I said, we're looking at fish encounters at different stations. So I could, of course, obviously make my stations wide, right? So in this way, I would say names from stations. So notice that instead of saying names to, so in his thing here, this is my homework, sorry. In his lecture notes here, you can see he has names too, because when you go from long format, sorry, when you go from wide format to long format, you have to give a new variable name base because it doesn't exist, right? So when you're going from pivot longer, when you're going from wide format to long format, you need to give it a name, basically, because no such name exists in the data frame. So I'm going to call it, so he calls it feed here, and he's taking the values too. But in contrast, when you're going from longer to wider format, you're going from values to a value. This is why your operation is now names from rather than names to, and you're going values from, right? So, and this is also why you don't give a range of options. So you can see here you gave a range of particular levels to your variable, but that doesn't really make any sense here, because it can read the actual levels within the actual class of from station. It will read and recognize how many levels it has on its own, basically. So when we actually run this, what do we get? So this is, again, the pipeline is going from left to right. So first I'm going to take fish encounters, and then I'm going right to the right, and this is going to pivot wider. And then, like I said, the names from and values from. Now, I will also point out that the pipeline, to get a new pipeline, which are these things here, for Windows, it's Control Shift M, but I think for Mac, it might be Command Shift M, right? So, and this is actually in my first tutorial, if you guys are kind of curious and you forgot, I put the commands there, right? So let's run this and see what we get. We get this data frame here. So notice that in contrast what we had before, we spread out the actual stations across each different columns, but this introduced a bunch of NAs. Why is that? Because if a fish was not seen at a particular station, there's no value of 1 there. So it just takes a value of NA because there was no observation, there was no sighting of a fish there, right? So we had to tidy this because you cannot do any kind of, if you want, if you want to do things like sum or means or variances, it will not actually run when you have NAs. It will tell you that you have NA. So you have to kind of you have to tidy this data up so you don't have to run into those issues, right? I will say that you can see from the first 3 fish types, they were seen at all stations, right? So if I literally just scan across my entire column, you'll see that every station contained these first 3 fish types. But for instance, with fish 4, 8, 4, 5, you can see that it was not cited at station B, C, E. That's why it has a value of NA, right? And it was not cited at, like, let's say station B, C, W. So this means we actually know how to fill in these values, right? Because obviously a value of NA constitutes a, kind of a value of like 0, basically. It means if there was no sighting. So we already know how, in some sense, we can fill out these values, right? And so it's a matter of like filling them out, obviously. This is why I'm going to say something like values 2 equals 0 here, right? This is because I know that the value, if it's not 1, it's 0, as in the fish wasn't cited there. Please be careful with this, right? Don't put value equals 0 unless you know that it's 0, because actually I could fill in any value I want. I could even fill in 1 or 2 or whatever, but you shouldn't fill in a value unless you know what the actual value happens to be. Logically here, it makes sense that it's 0, as in like the fish was not cited, but you shouldn't be quick to put any missing value there unless you know what it is in general. Basically, it wouldn't necessarily be correct. So we need to be a little bit careful, right? So if I fill in the values with 0, what do I get? I get a new data frame that will actually show the following, right? So what I have here is release, I80_1, all these stations now have values of 0. And the importance of this is that if I want to do things like sums, so let's suppose I wanted to select certain columns. So if I didn't care about all the stations, I only cared about some of the stations, right? I could literally select based on certain stations, right? So you can use a select function if you want to, right? So select across the columns. Maybe I'll make a note here because that's actually an important thing to recognize, right? So note, the select function in tidyverse allows you to select certain columns, basically, right? Right, so in contrast, I'm just going to, because you might get confused by this. In contrast, filter allows you, the filter being this function here, which I'm going to use in a second, allows you to select certain rows, basically. So this is an important distinction, basically, right? You need to be careful. They're not doing the same thing. One is working along the column space. One is working on the row space. So if I wanted to select, for instance, maybe I wanted to select release. Maybe I wanted the release, and I wanted these 2 rows here, basically. Right, I'm just going to do this. Just I'm a bit lazy. I could do something like this, select release, or let's say this, right? Something like this. I could do something like this, and it would just, this thing is meant to actually, indicate or. So maybe I'll just kind of do the following. So maybe I'll just kind of I'll make an example here. So I'll just say example, may select the first 2 columns That vertical dash is meant to indicate the OR function. Right, so if I want the first two columns, that's what I'll do. Or I'll even do something like, yeah, so I think I'll just probably just say release of like, I'll just say select these two rows. I can even do something like select of like, I think you can say whatever you call your data frame. So maybe fish encounters. So you can do something like select fish encounters of 1 to 5 or something like, or something like the following. I think this may even work, but you can check basically select of, let's say, fish encounters, something like, 1 to 2 may also work. You would say select the first two columns basically, right? So this is operating along the column space. In contrast, which I'm going to show you now, filter is actually looking at the row space basically, right? So maybe I'll just kind of do this, just to kind of make it grammatically low. Yeah, so keep this in mind. Don't confuse the two things. If you're asked, for instance, an assignment to select fishes within the range of like 4842 to 4844, which I'm going to show you now, you're being asked to filter based on the row space. If you're asked to omit certain columns, you're being asked to use select function. So you may be asked things in assignments, make sure you know which one you're using. So now let's suppose we're just looking at the fish within a range of like 4842 and 4844. Now, certainly, whenever I want to select a certain row, it may make sense to use logical operators. So what are logical operators? Things like equals, not equals to, less than, greater than, or like and or. But you can see from this data that you only really have 3 different variables. That is the station type, fish, and whether or not the actual fish was seen or not. So seen, station, and fish ID are the only 3 variables you have. So it doesn't make sense to use logical operators here, as in like look for instance, if you wanted to look, for instance, fish within a certain weight. So fish within the range of like this to this. You cannot use logical operators because you have no such variable, basically. Right. So when you don't have enough variables to do any kind of logical operators to select or to subset your functions, to subset your data, one thing you could do is use instead the in function. So I'll repeat again. If you don't have enough variables to use logical operators, like select variable X within a certain range of weight or within a certain range of height, because you don't have that information here since you only have 3 variables. One thing you could do is use the in function, which then tells you to select observations within a particular range directly from the column vector itself. So you're directly selecting from this vector here, and you're selecting across the row space. So instead of actually looking for conditions in this space here, because you don't have any, you directly select from the columns themselves, and you select across these rows in the row space here, right? So so this means I'm going to do what from left to right. I'm going to create a new data frame called fish underscore encounters, and I'm going to 3R base, because I'm like reduced from fish encounters 3, and those fish encounters 3 where I filled in the values of 0. So I'm going to filter so I only get the first 3 observations, which is kind of funny because, as I said, those are the observations for all the fishes we're seeing in each station. If you have a look and see, right? But let's, for illustration purposes, just pull it up. You'll see that it's in my, not only did it run the console here, but it's also my environment. So it's this thing here. You're only going to get 3 observations. Right? So you see the data frame looks like this, and you just look across all the stations, and you can see that a fish was seen of each of those 3 different types in every single station, right? So this is not particularly very useful, because if you want to know, for instance, which stations had the most fish sightings, you wouldn't want to pick the fishes that were seen in all these different stations, because it doesn't tell you anything, basically, right? So this is just for illustrative purposes, but it doesn't really make sense to pick the fishes that were on all the stations and say, hey, which station is more popular, because they all have the same counts in this data frame, right? So let's then go back to the initial longer format to answer such a question. So how many fishes are seen within each station? Like I said, we generally tend to prefer longer format, just because it does, make sense if you want to do things like taking means across groups, to have the levels of a particular vector of a variable presented in the same in the column space, right? So with the example of pigs where you had feed 1 to feed 4, it makes sense that if you want to know how the weights vary across each different feed, you would have feed 1 to feed 4 in the same variable called feed, and you would group across the different feed types basically, right? So longer format makes sense from a framework of wanting to actually look at things like sums or variances or means or whatever, right? So this is a pipeline in tidyverse, right? So, and you can see that if I were to actually compute this, or if I was going to build this data set, and what I've made here is a count. So how many fishes are within each particular station. If I was going to do this in base R, right? So instead of actually doing this tidyverse thing, I did it in base R. It would take me more lines of code than this, right? Because first I would have to actually sum of all the actual, use the built-in base R sum function to, right, and also use the aggregate function. So there's something called aggregate, which you probably used in earlier on, right? So I'd have to use this to create different, obviously, means for the different groups, and then I'd have to actually create, I'd have to append this to my initial data frame, and then I would have to actually use a sort function in the base R and then append that as well. And you would see I would have more lines of code in base R than I would from tidyverse, because with tidyverse, what you actually do is you actually append a new action from left to right. So in the first action here, what I actually was, I created, I took the fish encounters data frame and I created a grouping. And you can see that if you run this thing here, you just literally run this line here, it doesn't do anything in the sense that if I look at this, all it does is internally in the global environment, it will store the idea that I wanted to group it by the stations, but I haven't given any operation. I haven't asked to do a mean or any kind of thing or a count. So in this way, all it does is internally it stores the idea that I want, right? I want some kind of grouping, but it doesn't actually show up in the data frame because I haven't asked for any operation to be performed, right? So now let's suppose you wanted to sum up all the fishes, right? And you didn't actually first group it up. What would actually happen? Well, if you wanted to sum the if you just did sum of the fish, if you just something like, if you remove this grouping by station, you just did summarize scene, all you would get is 114, because you can see from the data from there 114 observations. So if you skip the group by station and you just put sum of scene, all it will do is give you 114 as a count, because that's how many observations you have, but it will not give you the count by station. So you wouldn't have actually done the operation you wanted to do. So when you're doing these operations, these pipelines in your assignments, you have to think logically about the order of operations basically, and think about how you want your data frame to look, because the operations are going from left to right. So please, in your mind, make sure that the operations themselves are following the same flow of left to right, which means that when you start off from the left, the operation that is the left to the right is happening first, basically, right? So first you group by, and that's happening to the left of the right, which is the next function of summarize, right? And then I summarize according to scene. So if I just run this, I'm going to get an unordered thing. So if I pull it up, you see that I get, oops. Oh, that's not right. I forgot the closed packet here. So if I just look at this part here, and I don't add the arrange, it will give me the following if I don't mess up this time, right? So you can see that it's not ordered. Actually, it actually is ordered here, ironically. But generally speaking, ironically, it's actually ordered here. It's kind of funny, but if it's not ordered, although it actually is here, it should actually order it in this instance from the highest to lowest. And actually, I think it does here for some reason. I don't know why. It's probably because I ran it beforehand. But anyways, you can see that if I didn't run it beforehand, which I kind of did because I was another tutorial, it wouldn't be ordered up. So you need to actually force be ordered from the lowest to highest, because that's the natural order of numbers to go from low to high, basically, right? So if you wanted to go from the descending order, you need to force it, basically. You need to arrange it in such a way. But you can see that released and 180 underscore, I think that's actually I80_1, both have 19 fishes, and then everyone underneath them has less number of fishes, right, in a particular MAW and MAE have really low number of sightings of only 5 fishes each, right? So this is how you can even make box plots with this, by the way, because now that you actually have, not box plots, sorry, bar graphs. Now that you actually have this tibble of like 11 by 2, you could actually create a bar graph. You cannot create a box plot because this is a discrete, these are discrete things, like station is discrete, right? It's not actually a continuous thing. So you could make like a, like a bar graph, right? Based on this, you cannot make a histogram. You cannot make a histogram because, of course, this is not actually a continuous variable. These are discrete things with nominal levels, right? So you cannot order up these stations. So these are nominal variables, nominal scale of measurement for the categorical variable. So the only thing you can actually make is a bar graph. You cannot make a box plot. You cannot make a histogram, right? So those are for continuous things, but you could obviously, you feed in this information to a ggplot and use bar and geom_bar. So let's switch up a bit. Let's go back to our empty cars example because I always use it in every tutorial, so it wouldn't be complete if I didn't. I just want to point out that tidyverse has 2 functions that allows you to make kind of data frames within that library. The first one is tibble. And whenever you have two vectors you created or 2 vectors you want to pull from an existing data frame to make smaller subset data frames, right? So I want to make a subset data frame based on vectors that exist within a different data frame, right? And you can use tibble because it will actually just join those 2 data frame, those 2 vectors together to create a data frame. So if you remember, base R has something called data.frame, right? In contrast, tidyverse has as.data.frame, which does make similar to data.frame, and you might ask, how is it different from tibble? And I think that whenever you have, like, let's say, an array or like a list, and you want to unlist it, or you want to actually create you want to create a data frame, you may use as.data.frame to kind of remove the array format and make it a data frame basically. So I think that they're doing tibble and as.data.frame do similar things, but I think you might use the second one when you have like arrays or lists. You want to actually unlist and you want to make them into data frames themselves, right? So, but they do similar things. In like, if you pull 2 vectors from a data frame and you use as.data.frame, it'll do the same thing as tibble, right? So I could have used as.data.frame here, and it would do the same thing as tibble does, right? So now let's remind ourselves of what the actual empty cars looks like. There's too many variables basically, so I don't want to use all of them, right? So if you scan like this, you'll see that there's a lot of them. So I just took a tibble of just 3 of them, right? So I just pulled up 3. So here they are. And we can do kind of cool things with this, right? So one thing I could do if I want, I could actually go from, I guess, maybe see if I can actually do that just out of curiosity. I'm not sure. Last time I tried it, it didn't work because there's a bit of an issue with the numerical structure of the cylinder thing, but let's see if, or with CYL. But I'm gonna see if I can kind of do this and let's see. If it doesn't work, that's fine, whatever. But what I want to do is I want to do pivot. I want to see if I can go wider and do something like, 4 to 8. I want to do something like, okay, let's see. So if I wanted to go from longer, okay, so I guess some names, it would be names like, from, so CYL, and then names or values from. Let me just make sure it's values and not value. That will not work if I'm not being careful. Yeah, it's from. So I'm going to say, let's suppose I want to go something like, I don't know, weight, I suppose. So let's see if weight works. There was a bit of an issue beforehand because I don't think that it lets you feed numbers as categorical things. So if it doesn't work, it's fine, whatever. But just curious if it actually works. So let's see. Oh yeah, it does work. So you can see that it does the following. So if I create a new data frame from, so what did I do here? I kind of went from long to wide, and wide in this instance here is I went from the cylinders, because there's if you look at the cylinder variable here, there's actually 3 different cylinder classes, 4, 6, and 8. So I went based on from cylinder and then values from weight. So I want to actually put weight across the, and actually you could put 2. If I do something like this, I suppose I could do something like C of weight and MPG. Let me see if it works. Yeah. This is awful, but you see what it does? It does this thing here. It combines them across like the different, because there's two different categories. There's weight and MPG. It will take each weight, but it will say, okay, weight for 6, weight for 4, weight for 8, and then it will say, okay, like MPG for 6, 4, and 8. So it looks really awful, right? So, but if I just do it in terms of one category, that's why we don't like wider format, because it doesn't really look great most of the time, right? Let's go back to weight, for example, and we can see what it does. Again, it creates this ugly mess you saw with the null before, because you may have, for instance, yeah, so if you look at this, it will do 25 observations, it will do null, null, null. That's because when you look at it like this, so for instance, category 4 doesn't have an MPG of 21, so it will put null. And then category 8 doesn't have an MPG of 21, so it'll put null as well. So you'll see a bunch of nulls wherever you don't have an MPG, for instance, of like for that category. And the issue with this is that, unlike in the previous example here, where we're able to put in values of 0, we don't know what those values would be, right? So this is why you don't really use wide format, but just for illustrative purpose, I thought I would show you. But we wouldn't really use wider for this particular data frame, because it doesn't really make the data nicer for us. It makes it worse in some sense, right? So I'm just putting a note here for illustrative purposes. Yeah, we won't use it because it's messy. You can see you get a bunch of nulls, so you in some sense haven't made it any easier for yourself. But now I said beforehand that we couldn't really use logical operators in the fish data set because there weren't many variables. All we have is fish type, station, and whether or not the fish was seen. But let's suppose we want to actually use logical operators here, because we know from the cylinder data frame, right, that we can use. So the reason why we can use logical operators here is because we want to, for instance, subset cylinder type based on weight. We can do now. We now have a condition we can actually force. We can say, look at weight that's within a certain category, and that becomes a logical operation we can perform basically that will give us values of true or false. So the value is like, if your weight is, when you put weight between like weight bigger than 2.8 but less than 3.2, whenever the weight is actually when the weight is actually, you know, not bigger than 2.8, it will say false, and it will not include that in the actual data frame. Similarly, if the weight is actually bigger than if the weight is actually bigger than 3.2, it will say false, and it will not include it in the actual filter. So this is a logical operators give you a value. Their logical operators are actually statements about the truth, right? So when you put these conditions as, is it equal to, is it not equal to, is it less than or bigger than? Whenever it says false, it will exclude those falses in your data frame basis. So it's always going to evaluate a condition about the truth. And when the truth is not, when the truth is not true, as in when it's false, it will drop the actual data frame, the observations in the data frame, right? So here the logical operations is equal to is this one, not equal to is this one, less than, obviously bigger than. This is or, and this is and, right? So now let's suppose we wanted to know the cylinder class, for what cylinder class is most common for a weight between 2.8 to 3.2. So I'm going to create a weight data frame, you know, and call it from the, and I'm gonna extract from my cylinder data frame I created, not the initial empty cars because it's too big. This data frame I created called cylinder, right? So I'm going to filter in such a way that when the weight is bigger than or equal to, bigger than or equal to 2.8, so I'm using both this condition, right? I'm using both this one here and also the equals, right? So when it's bigger than or equal to this, I'm gonna pull it in. It's gonna be true. Also, When it's less than or equal to 3.2, that's also true. But if it's outside those range, it's false. I want to point out this comma is which is and is working the same way as this thing here. This is and, but also this is also and. When you have this comma, so if you change this comma to like and, it will still run the same. It will give you the same output base because it's performing similar operation, the same operation basically. Okay, so now let's see. Right? So you can see that we got 4 observations of 3 variables. So this is, I can pull this up and you get this. So now the question we asked was how many are, or what is the cylinder type with the weight between 2.8 and 3.2? Like what's most common? And we can see that actually the cylinder type of 4 is most common for weight of like that's in between 2.8 and 3.2. So that's probably the lighter weights. And I guess it makes sense that it's probably around 4 is most common. I'll also point out that notice that MPG, this is actually a funny thing I noticed in the previous tutorial where I said that I expected that your miles per gallon would actually go up if your car was bigger. But it turns out that logically I realized that it's true from a physics perspective. That whenever you weigh less and you have a lower center of gravity, you move faster, right? So you accelerate faster right? So we know that we know that you accelerate faster if you weigh less, right? So if your force of gravity is low and you weigh less, if you think about it in terms of even long distance runners, they tend to be petite, like center of gravity is low, they're light, right? And they move faster. So it makes sense that the cars that are heavier move slower, as in their miles per gallon is actually less than a car that is actually smaller. It's moving the fastest. In fact, cylinder class of 4 is even moving marginally faster than 6. And this kind of makes sense, right? And we can actually test my revised hypothesis like that. Now I think that cars that weigh less should, in some sense, right, move faster. Right. So when we look at and obviously this is a question about bivariate statistics, right? So whenever you have this notion of bivariate statistics, your instinct is first to look at a scatter plot of the points, right? So then I told the previous tutorial that naturally, when you're thinking about what is in the x-axis and what's in the y-axis, you're thinking to yourself, well, whenever you have a variable that's prone to measurement error, it would go on the y-axis when because there's a statistical noise or uncertainty that we cannot completely capture from just measurement alone, right? So whenever you have this error, there's a randomness that we can't completely control. And whenever you have values that are independent, like they're fixed, you put them on the x-axis, sorry. And most dealerships know the weight of their cars when they design them, right? So the x-axis naturally is weight because this is something that is kind of fixed. Most dealerships know the weight of their cars, but the number of miles you go per hour or per gallon can be temperamental based on like the weather, traffic, multiple measurement error, multiple things you can't control. So this is going to go on the y-axis. So then we can ask ourselves, is there an association? And if I just actually plot this, you guys know that it's going to only run, right? It's only going to show me the coordinate system, right? If I can ever get it to load. God damn this computer. Okay, just going to move this here for a second and run my little plot. So you can see that all I get is just this coordinate system where it actually plots on the x-axis the weight and the y-axis the miles per gallon. But now if I add, for instance, this geom point thing, right? What do I get? Well, I get the points without any kind of linear relation, any kind of linear line that I estimated through it. But you can see that it's pretty strongly negative, right? So we can see that my hypothesis appears to be a little bit correct, where if you add more, your actual if you add more weight to your car, the miles per gallon goes down. So you're in some sense limited by how clunky you are, basically, right? So this is a good thing to know, right? And now I can add a line of best fit for this, which is obviously going to be a linear line because you can see the relationship looks somewhat linear and decreasing. Right now, I want to point out the standard error equals true is the default. So if I put standard error equals false, I'm going to get a line that does not show the standard errors, right? So you can see here, I just get this line, which is pretty good, right? So the points don't deviate too far from the line. And you can imagine if I put a standard error on it, which I will in a second, it should give me pretty narrow confidence bands because most of the points are close to the line, which shows that it's a pretty good fit, right? So usually when you have points that are far from the line, you're missing something in your model, and your confidence bands will be wide as a consequence of this, basically, right? So not like I said, the default is to put the standard errors in, right? So if I remove this and I just run it like this, I get the standard errors that look like that. And like I said, it's pretty narrow, right? Because your points are pretty close to the line, so it looks pretty good, right? Given that we only have 32 data points. It's especially good in the middle when the points are really clustered. If you have more sparse points into the actual tails, the confidence bands are slightly wider because you obviously have less data, right? So you're estimating based on less information. So your confidence bands will be wider as a consequence of this, right? So intuitively, it makes sense. What you actually see in terms of the confidence bands, so you provide more information, get a better fit. Provide less information, right? Get a worse fit, right? So the more you move to the sides, there's less data, your approximation gets poorer, obviously, right? So this kind of makes sense. So yeah, this is kind of tidyverse. I think it's great because look at how few lines of code I used, and I got a lot of information, right? Whereas if I was going to do this in base R, I would easily have the page would be a lot bigger than this, right? So Ken used that when Ken first taught this course. It was actually kind of funny because when Ken first taught the course, it was interesting since he used base R and then at the end he taught tidyverse. But I think he realized that like logically, the point of this course is to actually provide you guys with the tools to begin data manipulation, data analysis, right? So when you want to get a job in data analytics or whatever, you wouldn't make any sense to start you off with base R because almost no one uses it anymore in very advanced settings because it's not clean, right? So the course was revised to kind of encompass tidyverse entirely because the universe is just cleaner, right? So it also more resembles, it better resembles SQL, right? So it's actually using similar ideas of pipelines. So in some sense, for those of you who end up doing a lot of data manipulation, when you move to SQL, it does give you a better framework to learn that pipeline, right? So in some sense, you realize that you're better equipped to learn tidyverse right away than to use base R, right? So that's kind of, I guess, the logic of why you started off with tidyverse. And you can see it's quite clean, right? So it's great as long as you remember that your operations are going from left to right, and operate accordingly. So don't perform operations you want to happen second and start from the left, or you have to put on the right, basically, the operation you want to happen first. Right? Any questions about this? I'm guessing no questions. So this should be a really cool assignment. I personally love when I get to fiddle around with tidyverse. So you were all very lucky to get to play around with tidyverse this week. I had to learn tidyverse on my own because when I took this course, it was called C32, and I don't think we learned tidyverse too much, but you guys are really lucky to learn it in this course. And I thought I think when I first started realizing how to use tidyverse, I realized it was so awesome and it's such a handy package. So yeah, like I said, if any of you are really curious about how to use tidyverse, or you're curious about the author of tidyverse, his name is Hadley Wickham and he's on Twitter. So feel free to play around and have fun beyond the scope of the assignment, which is what I would do if I was still a student in this course. But other than that, have a great afternoon, everyone, and good luck with the rest of your week.